Hello, in this lecture we'll be doing a similar problem as the previous one in this, but there's a difference. We have different compounds. We have 9% of magnesium and the rest 91% of iron. The question is, like the same one, what is the empirical formula? Okay, here we go. Now 1 mole of magnesium, how many grams? Let's see the periodic table. Magnesium, where is magnesium? Yes, 24. Go with 24 grams. One mole of iron, how many grams? Let's see the periodic table. Where is iron? Iron. Yes, over here. 127 grams. Okay, now what do we have to find? The number of moles in number of moles in 9 grams of magnesium, right? Like the previous problem, I'm not explaining it once more. Like the previous one, we assume that it is 100 grams of total, so we have 9 grams of magnesium. Number of moles in 9 grams of magnesium, which will be 9 divided by 24. Similarly, the number of moles in 91 gram of iron, right? 91 gram of iron. 127. 91 divided by 127, right? Okay, now we need to find the ratio, right? Okay, I'm taking this away, moving this off, and I'll be moving this upwards. Okay, I'll do it in another color. Now what do we need? We need to divide them, right? We need to divide 9. Oops, sorry, 1 2. Which color should I choose? Okay, 9 divided by 24 divided by 91 by 127, right? Therefore into 127 by 91. Is that right? Now I need the calculator. Okay, here I have it. 127 into 9 divided by 24 divided by 91. 0.52. Okay, we have a similar answer as the last one. 0.5 means 1 by 2. Therefore that is the ratio, 1:2. Now what is the compound? We have the compound as Mgi2, right? Mgi2, because this over here is magnesium, therefore 1 magnesium, and this over here is iron, 2 iron, right? Okay, therefore the compound is Mgi2. Sure about that, right? Okay, we will do a similar problem, not a similar one, a different one, sorry. Okay, first I need to clear all this. Poof. Okay, in this question it is given that there are 3 percentages. Unlike the last ones, there are 3 different percentages. Okay, the first one, let me write it down. Sorry. Okay, yes, the first one is 2.04 percentage of hydrogen. Then we have 61.3 percentage of oxygen. Then we have 32.65 percentage of sulfur. We need the empirical formula. Sorry, we need the empirical formula. This question, Okay, something similar to the last one, but in this we have 3 instead of 2. Okay, let's start doing this. So like in other problems, we will consider it as 100 grams. Okay, we write it in a similar way. 1 mole of hydrogen. How many grams? You know that the atomic mass of hydrogen is 1, therefore 1 gram, right? 1 mole of oxygen. Oxygen. I know the oxygen atomic mass. Just to confirm, 16, right? 16 grams. Okay. 1 mole of sulfur. Now what is the atomic mass of sulfur? Sulfur, 32. Okay, write it, 32 grams. Okay, we have this data over here. Now let me remove the question. Let me remove this. Okay, I need to place this over here. Okay, I'll do it in another color. Now number of moles in hydrogen. Oops, not two. Number of moles in hydrogen, right? In H. Sorry, number of moles in, not H. We have how many grams of H? 2.04. In 2.04 grams of hydrogen. How much? How many moles do we have? We have it as 2.04 divided by 1, right? We have the atomic mass as 1 gram, or the molecular mass as 1 gram. Okay, the next one, number of moles. Number of moles in how many grams? 16 grams. Sorry. What is the percentage? You know, even though I rubbed it, I have the question over here. Please note down. 61.3 grams of oxygen. How much is that? 61.3 divided by 16, right? Okay, the last one, number of moles in what is percentage? 32.65. 32.65 grams of sulfur, right? Is equal to 32.65 divided by 32, right? Okay, now I hope you know how we got these grams. In the question it was given this much percentage and we took it as 100 grams, so actually this will be the grams, that percentage. Okay, now we need to find the ratio, right? Okay, we will first divide all these in, right? What is 2.04 divided by 1? It's 2.04, right? Now what is 61.3 divided by 16? What is that? Let me do it in my calculator. Yes, 61.3 divided by 16. It's 3.83. Let's take it as 3.8. 3.8. Now what is this? This is almost 1, right? 1.5. Say. Okay, we'll take it as 1. Okay, what is the ratio of number of moles between, I'll do it in another color, I'll do it in gray. Okay, what is H is to S, H is to H is to O. What is that? What is H? 2.04. 2.04 is to S, 1. Sorry, this is actually point. Okay, is to 1 is to O, 3.8. right? Now what is this? We can approximate this as 2, this is 3. Sorry, this is 3.8, right? So we can approximate it as 4. Therefore it's almost 2 is to 1 is to 4, right? Give 2 to hydrogen. Let me write it now, the color H2 1s O4. And I'm sure that you have heard of this compound. This is sulfuric acid. H2SO4 is what? Sulfuric acid. Sulfuric acid, right? Okay, but in America they write it instead of this instead of this pH we write it as F. We can write in both ways. If you search in Wikipedia you will get both ways. Okay, so I hope you have understood how to solve such a problem when it comes 3 or even if when it comes 4. Okay, so I've run out of time. See you in the next lecture. Bye bye.